All right, guys, so circles today. I know you all know what a circle is. We're going to go over some circle vocab and then a couple practice problems, and that's it for today, okay? So let's start off with, let's just start off with the radius and diameter. So those are two that you're probably already familiar with. So naturally, you have a circle, and the center of the circle is obviously in the middle. We name circles by their center point. So it's really kind of nice. So if I wanted to name this circle A, I literally just named the center point A, and there's circle A. So naming circles is super easy. Okay, so let's just go ahead and do some circle vocab. Oh, there's a symbol for circle, which is literally just a circle with a dot in the middle.
Whoa.
What'd you say?
Whoa.
Whoa or blue?
Whoa.
Whoa, I know, it's so crazy. Circle vocab. All right, so let's start off with radius. I know you know what a radius is. It goes from where to where?
Middle to end.
That's it. That's exactly it. So the radius literally just goes from that center point just right to a side. So there is a radius. Every single radius that you draw in the same circle is going to be the same measure. So if I told you that that radius was 7, if I drew in another one over here, it would also be 7. Another one over here, it would also be 7. They're all 7, which is so nice. So in one circle, all the plural form is radii. All the radii are going to be congruent to each other. So first of all, a radius is a segment from the center to circle's edge. That's it, from the center to the edge. And if you want to add all radii in a circle are congruent. So you can draw in as many as you want. And that's another cool thing. If one's not drawn, you're allowed to just come in and draw another one if you feel like it. You can do whatever you want, and they're all going to be the same measure. As long as you're in the same circle, of course. If you have a different circle, then they'd all be the same in that circle, but not every single circle has the same radius, of course. Anyway, so there's radius. And then, always tied to radius is the diameter. Diameter. So a diameter is just a segment that goes from one side of the circle to the other, but it has to pass through the center point. So it's basically just like two radii back to back that make a straight line. All right, so a diameter is a segment from one side to the other that passes through the center. It has to pass through the center. If it doesn't, it's not a diameter. It's something else. I wonder if anybody knows what the word is for the other thing. Anybody happen to know what a segment that goes from one side to the other but doesn't pass through the center, what you would call that? What'd you say? But it has a special name in circles. So let me draw for you a diameter. So it's going to start, it can start anywhere on the circle, doesn't really matter. And then it's got to go through the center. I didn't do a very good job. Straight line passes through the center. So that whole green thing would be a diameter. All right, so some interesting things about the diameter before we move on to other things. We're going to add that it is equal to 2 times the radius. Which makes sense because it's really like here's a radius and then here's another one. So it's like 2 radii put together back to back makes a diameter. So if I know the measure of a radius, I can figure out the measure of the diameter. I would just double it. Same thing going the other way. If I knew the measure of the whole diameter, I could find the measure of a radius just by cutting it in half. Okay, so diameters are equal to 2 times the radius. They also divide the whole circle in half. So you now have these 2 half circles, which we refer to as semicircles. So it just like completely divides the circle into 2 equal parts. So let's add that. Each diameter, well, I'll just say a diameter. A diameter divides circle into 2 equal halves called semicircles. Whoa, wrong way, sorry. Okay, so the word I was looking for before for a segment that has its ends on the edge of the circle, but it doesn't necessarily go through the center, it was chord. Do you remember hearing that word with reference to circles? Chord, but it's spelled like chord, C-H-O-R-D, but you say it chord. So I don't think that I do, we're not going to be doing any work with chords in this class. Unfortunately, they are super cool and there's all these neat things that you can do with them. We just don't have the time. So I will just throw their definition up here, but we're not going to really be looking at them. So a chord, spelled like chord, I know. It's just a segment with both its endpoints on the edge of the circle. So a diameter is technically a chord because it does have its endpoints on the edge of the circle. It's just a special type of a chord that happens to go through the center. But so anyway, chord, segments with both endpoints on edge of circle. All right, so there's the definition of it, and you know, just so you have it, but we're not really going to talk too much about them. What we are going to talk about is kind of what happens when you have radius and diameters meeting, and then you have all these angles that get formed. Do you see all these angles here? You've got a little angle here, a bigger one, and then sort of a straight angle right here, if you will. So those are all called central angles. So those are really kind of cool, and there's a whole bunch of neat stuff that we're going to do that's actually really easy. So we're going to do that. So let's get their definition up here, and then we'll talk about some. So a central angle, its definition is really easy. It's just an angle whose vertex is at the center of the circle. Angle with vertex at center of circle. And the really cool thing about central angles, so if here's my circle, here's the, by the way, when you put a dot in a circle like that, it's always assumed that that dot is the center. Okay, so we're not going to be like, ha ha ha, that wasn't actually the center. If there's a dot in there, you can assume that it's the center. All right, so there is my center point. So to draw a central angle, I would just go ahead and draw an angle so that its vertex is at the center. So this right here is what we refer to as a central angle. Now, here's what else is cool about central angles. So in a full circle, if you go all the way around a circle, how many degrees is that? 360, exactly. So to find the measure of a central angle, see how each central angle here, right? So let's look at this one. You end up having this part of the circle that's sort of like in between, on the inside of the angle. That there that I just drew in green, that's called an arc or an intercepted arc, okay? And you have small arcs called minor arcs and big arcs called major arcs. And here's what's so neat. The measure of the central angle is the exact same as the measure of the arc. They're the same. So if that's an 80-degree central angle, that means that this arc has a measure of 80 degrees. That's so neat. Okay, so let's kind of get this in words because this is important. So let's say each central angle has an intercepted arc. The measure of the arc is equal to the angle. That's so cool. So on your homework today, you're going to have stuff that looks like this. I'm going to give you some sort of a circle. I'm going to give you a central angle, and I'm going to tell you that the central angle is, I don't know, let's say it's 40 degrees. I am then going to be asking you, let me zoom in on this a little bit so you can actually see it. I'm going to say, okay, well, what's the measure of this arc? By the way, how do you name an arc? You just use the letters on the end. So if it's like EF, for example, and here's how we do it. We put an arc, and then we put the letters EF underneath. So you don't do a straight line like we did with segments, because it's not a straight line, right? So you put a little arc, and then you put the letters. So that arc right there, EF, would have a measure of 40. It's just the same as its central angle. That's it. That's really easy. They're exactly the same. Okay. I mentioned briefly that there's major arcs and minor arcs, so let's just add that real quick. A minor arc. Oh, look how I spelled arc. Oh my gosh. Silly goose. Let's fix that. A minor arc measures less than 180, so less than half the circle. A major arc that's going to measure more than 180, so it goes for more than half the circle. I know what you're thinking, or maybe I'm just hoping that you are thinking this. If you're looking at this diagram right here, right, and you're talking about minor arc EF, what if you wanted to talk about this arc, this major arc that went all this way? You couldn't call it arc EF because arc EF is this little one. So how in the world are you supposed to like tell people, hey, I want to talk about this arc? Well, to name a major arc, you actually have to use 3 letters. So there would have to be another letter somewhere on here. So I don't know, let's just put a point G here. So if I wanted to now talk about this whole thing that went all this way, I would just have to call it arc EGF, or you can go the other way around and say FGE, but you're just going to name the letters in order as you pass them, going one way or the other. Okay, so major arcs are going to be named with 3 letters, not just 2. Okay, so let's name major arc. Arc EGF, just like that. Can anybody tell me what its measure would be? What would have to be the measure of this whole thing? EGF.
320?
Yes, because remember, a full circle is 360. So all the way around would be 360, but you already have 40, so that leaves 320 degrees to be that major arc, which makes sense because I know it's got to be something bigger than 180, right? Because major arcs are more than half the circle. Yay! So that's actually pretty much it. All I want to do is a couple of different problem examples so you can see how we can sort of put all the things that you know sort of together in some of this. So let me mark this is done for you guys. All right, and let's look. So I'm going to draw you a circle and I'm going to ask you, let's see if we can find some things. All right, so let's have a circle here. Here's another thing that you are allowed to assume. If you see this, you are allowed to assume that that's a diameter, okay? If it looks like it's a straight line, it's a straight line. I'm not going to be like, ha, 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 that wasn't a perfect 180 degrees. It was 179. No, that thing is a diameter. If it looks like a diameter, it's a diameter, okay? So let's put a couple of things here. And all right, let's just start with this. So let me give you some letters. A, B, C, D. Let's number some angles. Okay, if I told you, let me zoom out a little bit. If I told you that arc BA was 60 degrees, let me try this marker. The green never shows up very well. Try blue. That's a little bit better. All right. If I told you that that arc BA was 60 degrees, can you find for me the following? Find for me the measure of angle 1. Find for me the measure of angle 2. Find for me the measure of arc BC. Find for me the measure of arc ADC. Oh, you know what? And let's go one step further. Find for me the measure of arc ACB. Ooh. Oh, wait. I meant angle right here on number 4. Sorry. All right, see if you can find me those 5 things, given just that one little bit of information that I already gave you. I'll give you, like, not a ton of time. Okay, we got some answers here. All right, let's see. Shout it out if you know it. What's the measure of angle 1?
60.
Yes, 60. It's the exact same as the measure of its arc. If that's 60, that's 60. Easy peasy. All right, what's angle 2 going to be then?
120.
Yes, this is a diameter. So that means that these two together make 180. So if that's 60, this is 120. In fact, let's put it in there. You're 60. So now you're 120. So now what's the measure of arc BC?
120.
120. It's the same as its central angle. Exactly 120. Now, angle ADC. What's that?
180.
180 because it's just a straight angle. Exactly. Now be careful. Arc ACB would be this whole arc. You start at A, right? And then I'm going to go all the way. You know what? Hold on. Let me do a highlighter thingy. I start at A, and then I go all the way around to C, and then I go all the way to B. So it's that whole distance. Anybody have it?
300.
It's 300. Yes, and you can get there two different ways. This whole thing is 180 plus another 120. Or you're doing the whole circle except for that 60. So you could have done 360 minus 60 as well. So either way you slice it, you should have gotten 300 for that major arc. Okay? The only other thing that I want you to be aware of is that you can have vertical angles in here. So there's a diameter, there's another diameter. If I told you that this arc right here was 50 degrees, right, and there's my central angle, that means that this angle is 50 degrees, which also means that this one's 50 because those are vertical angles, right? Anytime you have two lines that cross like this and they're straight lines, you get that pair of vertical angles. So this is also 50. So then that means this arc right here would be 50. Which also means, can anybody tell me what the measure of that is? I'll be so excited. Who's got it? Come on, come on, come on.
130?
It's 130! Yay! 130. Why? Because these two together make a straight line. So they have to be 180. So that means this one right here is 130, which means this one over here is 130 because they're vertical angles. So I know that there's at least one or two problems on your homework that have some vertical angles. So just don't forget about them. Okay? But that is everything that I need to talk to you about today. Well, there's so much. I mean, my gosh, we could do an entire course on circles, not even kidding. But I am going to make the homework live right now. I'm also going to do a couple of them out if anybody needs that. But if you feel ready and confident, then you can go right ahead. Once I find where, oh my God. There it is. Okay. This is going to be homework number 28. There it is. Sorry, I forgot to save this. Jeez Louise. Can I save it? Oh. Cancel. File, save as. Sorry. FT. Save. Okay, got that done. Now I want homework 28. All right, here it is. Let's post this. I don't need the camera in my face anymore. Scramble choices, give additional. You guys are B block, and this will be due tomorrow. All right, so the homework is posted. It's on CUDA. I am going to go ahead and do a couple out. There we are. Okay, so in the first group here, you are just going to be asked, oh, what's the matter with this thing? Why is it showing? It's like not showing the whole screen right. Let's try this again. There we go. Okay, so they're giving you an angle. They just want to know the arc that goes with it. That's all. So this should be pretty straightforward. Angle 1 is right here, so its arc is just this one. ML or LM, it doesn't matter how you, which order. So that one's just choice D. Okay, easy peasy, hopefully. So you're just going to have a couple like that. Angle 1, that one's just FG. They might switch it up and give you the arc and say, okay, well, what's the angle that goes with that? So that's all they're doing in this case. If they're talking about DE, what angle goes with it? It's obviously angle 1. That's the only angle that's there. So that one should be pretty easy. So EQF. This time they didn't use a number for the angle. They used the name. So there's EQF. What arc goes with that? Well, wouldn't it be this one? EF? That's all. So that's what this first section is. And then let's fast forward. Okay, then we're eventually going to get to measurements. So here they gave you the arc is 135, so its central angle is just 135. So you're going to have a bunch that are super easy like that. So here they gave you the angles 30. They're saying, okay, well, what's the arc? 30. They're the same as each other, so nice and easy. Oops. EFD. Okay, this one's a little bit trickier. They want the measure of EFD. So that would be from here to here, all the way to here. So you know this part's 127, but you need to add on to it whatever that is. Well, I don't know what that is, but you can find it. Because remember, if this is 150, that means this is 150. So I have everything in the circle except that one little missing piece. So I can do 360 minus 150 minus 127, and that'll give me this missing piece right here. Does that make sense? And then you could just add the two together. Oh my gosh! Real quick. Get out of here. So you have some like that. Just be careful. Don't forget about like this one. You're going to have to use the fact that that's a diameter. Right? Also use your, so if this is 120 down here, you should be able to find this one. And then don't forget, look, it's got a vertical angle. So once you find the measure of this one, you have the measure of this one. And then you can find the measure of that one. So give it your best shot. I know we're out of time, but give it a try. There's not many. I think there's only like 18 questions altogether. Oh, 20. That's it. Okay, guys. So thank you. Sorry we went a little long today, but we had those two fast 10s to take. But